Yeah, so I worked in Ocado for 6 years, and I traveled from Krakow to show you the journey I took with my team to from tests that were brittle and hard to maintain to tests that were easy to maintain and gave us real value. So, few years ago, we take over the app from team that had too much on their plate. This app had a lot of legacy. It was in older technologies. It ran on Kubernetes, and we were given a task to move it to more modern stack, to AWS, to all frameworks that are fresh and fancy right now. So. We calculated the time that we needed to move it as existing app and time that we needed to just write it from the scratch without any tech debt and in a way that we would like to have this app running. And the times were quite similar, so we went with the second option and we just write it from the scratch. That gave us a big opportunity to test some new approaches and compare them with the approaches that were used before in the company. And yeah, that's how the experiment started. So as the experiment, we decided to completely flip the testing pyramid. So we just thought we won't do unit tests, we won't do component tests, we will do some integration tests, but we will focus on end-to-end tests. In our mind, those end-to-end tests are unit tests, but we'll talk about it in a minute. So another thing that we wanted to change is what we wanted to turn the mess we had. So this is a simplified diagram that shows that up, and each circle or rectangle is a testing level. And it was a bit messy. We had, few testing levels. And every level, has different Spring context, is different from production because it doesn't contain whole application. So it was messy, and it was even hard to, decide on which level you should test. So we wanted to have simple approach, just one or two testing levels that would fit us and that would not cause any troubles. And in the end, we had a test that didn't change during refactorings, didn't change for the new features. For new features, we just added new tests. Each test was both documentation and protection from breaking the code. Each test accurately represented the actions of system user because tests were driven by API. And we didn't need any artificial test cases just to increase code coverage because your CI job was failing because you didn't cover some constructor in your class. And 98% of tests was written on a single test level, so it was much easier to choose the test level for tests. So that's just a teaser. And it's a promise, but let's see the whole story so I can show you how to achieve that. So I based this presentation of the Charles Dickens Christmas Carol, in Polish known as Opowieść Wigilijna. So let's get carried away with the ghost of testing past. Let's check how did we test our application before. I would say that our previous approach was the most common. I saw it everywhere since I left university. So it was classic with asterisk testing pyramid. It's asterisk because I noticed that every developer understands testing pyramid differently. So integration can be different for everyone and component. You have to discuss it before you talk about it. But in our approach, unit tests were written per class. We mocked all class dependencies. There were a few component tests just to test groups of classes that were well connected. We had integration tests for external components like databases, queues, and simple end-to-end test to prove that it works when you mix it together. When I asked around 20 colleagues in Ocado, both from UK and from Poland, I think that around 13 still use this approach. There were 7 that migrated to some different approaches, kind of our approach, but also hybrids. So I would say that it's probably the most common testing approach, but it becomes less popular with every year. So just to be on the same page, the sample test in this class-oriented approach would be classic test with some dependency that we mock, with some test subject that we inject mocks into, with a testing method that checks something, that something should be done. And yeah, so at the beginning we record that dependency when it's called should return something. Then we invoke the tested method and we see and check if the testing method returned the thing we wanted it to. So we had thousands of such tests. It checks the behavior of the class, but I don't think it checks the behavior of the system. And it's hard to maintain it, because if something inside the class changes, for example, the method it calls, it's broken. Yeah, and that's the diagram I showed you before. So testing levels in our previous approach, it's really messy. So you can see that we had some tests that tested whole application, but almost whole, because without queue, without the data events processor. We had some repository tests, barcode calculator tests, so some logic that's pretty complicated, so it has its own unit tests. And yeah, it was even hard to choose the testing level in such an approach. You never knew if you did it well, or if you forgot about some testing level, and we didn't have any test to check if we used all test levels that are required. So yeah, it was completely upon the developer and person that reviewed the code. And we didn't like that approach, because the first and most important thing, brittle tests still stolen the joy from our refactorings. Because do you know this feeling when you take messy code and you turn it into well-defined classes and methods, and this joy was violated by the need to fix tests. You didn't broke anything, but you have to fix those tests. It's, it shouldn't work that way. It's almost like, cleaning your apartment, and then you sit on the couch, you smell the chlorine from your bathroom and from your kitchen, everything is great, and then you remember that you have to clean your basement. And it's messy, you don't want to do that, but it has to be done, because otherwise your CI will fail and it won't work. So brittle tests still stolen the joy from our refactorings, and that was the biggest issue for us. As I said on the previous slide, choosing test level is not obvious. The one test per class rule promoted big classes, because we are lazy, all developers are. And when developer can create one big class and one test for it, he will choose one big class. He won't create 5 classes, because it will be more work to create 5 test cases, 5 names for it. Yeah, it promotes bad behavior. We also tested impossible cases, because we set up test state through repository, and you can do anything when you work directly on a database. And those tests were useless and pointless, because it could never happen on production. And one last problem, maybe not so visible, but still there, those test contexts, 5 or 6 contexts, didn't reflect the production context. So we tested the classes that were on production, but we didn't test it as a whole in the same way as it worked on production. So it didn't give us the safety that we would like to have, because it wasn't the 100% production. Maybe not 100% because it's hard to have tests that are 100%, but close to production. Yeah, but it was the only way we knew, and we didn't try to change it when we had a working app. But with the new opportunity came the change. So let's go with the goals of testing present. How do we test right now? So let's tackle the problems I talked before about. We have brittle tests, so let's test without assumptions on the code. So our tests won't mock anything. Let's just, anything inside the code base, let's just assume that our system is black box and we don't know anything about code structure. Choosing the test levels is not obvious task. Let's have one testing level. It's not really one, but almost everything is tested on that level. Huge classes promoted by one test per class. Let's test features. So every test can be about and around business feature and need, not about classes. We test impossible cases. Don't use repository. Test through public API. This way you just use system as a user would use. So there's no way to set up impossible state in the system. And about the test contexts, let's run the tests on the whole system. So if the system is run as the whole and everything is tested on that level, you are much safer than if you have 10 testing contexts that doesn't reflect production. So to sum up, our tests, we ended up with tests that were black box, oriented around features, changed only when requirements change, and invoked the system as the user would do, so through the API. We wrote them on one testing level, using the same context, so we didn't have to load that context on every test, it was reused. Yeah, so that's all from this slide. And that's the sample test from our domain. We have test, it extends the API test base just to have easy access to our API in every test, so we have some tools underneath the test base class. And this test is about creating and then removing a container from our system. So we use API helper from test base to create container. It just invokes the REST API endpoint in the system. We delete it through the API and then test if it was removed through the API. All those methods are used by our clients in system that don't have methods that are needed, for example, for assertions. We just add such methods in the test context. Yeah, so that test is quite similar to the previous one. It has just given when then, but it tests the whole context, whole path to the system, and it won't break if you change something in your code, like class structure, methods. It just works. And regarding the test levels, that's our current testing levels. So we have one big test level for the whole production context. And as you can see on the bottom, in the tests, we just replace external dependencies with some mocks. So we have test database instead of AWS database, the same with the queue, the same with data store, and yeah, that's all. We still keep unit tests if we need those. So For example, we have complicated barcode calculator that has some algorithm that transfer, the barcodes into weight of the item. So, yeah, we could test it through the API, but it doesn't make sense, going through the whole system. So if we have small complicated algorithm, we still test it in the unit class-oriented style because it just makes sense. But yeah, you don't have to wonder where to put your tests. But we had some concerns, especially when we didn't know how to write those tests and we were before the migration. Our first concern was if those tests won't be hard to write and hard to read for the users. And we found out that it's actually easier to test such tests, to read and write such tests, because as a person that tries to step in the shoes of the user, you can read this test as the documentation. So you can see that user can create container, then remove it, and it's just easier than looking at given some mock returns that, then that should happen. So yeah, it's easier from our perspective, but I have to confess that it applies to backend business apps, so apps with public API, with logic, with state. I'm not sure if it will apply to other types of domain, like batch processing or some complicated distributed computations. We would have to check, but we don't have such an app, so we didn't. Our other problem with that approach was the concern about test duration, and it's the biggest problem with that approach. So in the previous old approach, when you run tests, it works almost immediately. A few seconds, you see it's green, it's red, you can fix the logic. But such a test with a new approach can run for almost 44 seconds because the whole context have to start up. It's slightly better with this new Apple silicon, so M1, M2, M3, because it's half the time, 20 seconds, but still single test runs very slowly. And if you work in a TDD, especially the default original short loop TDD, so you run tests on every change, you check if it's green, then it won't fit you. It's just impossible to work this way. Yeah. Yeah, because if you don't have to test every class, you can have less tests. Yeah, but there's less tests, but bigger coverage. Yeah, so it's slow to start single test. It's much better when you compare duration of all tests because we load the context once, so it's pretty similar. So all tests run 15 seconds longer than in the old approach. And we were very happy about code coverage because it raised from 71 to 97 because when you test the whole logic through the system, almost everything is touched and covered by the tests. But as you can see here, it's not a silver bullet. It won't work for everyone. It has some big minuses in here, cons. So, just to sum up, there were many pluses for us, especially tests that are not broken by the refactorings or changes, non-functional changes, but there were also many cons, so that execution of single test that takes 44 seconds was a big con for us. And another con that I didn't talk about is that test setup was more expensive because previously with the repository approach we could just create a clever insert into database, one operation, and the test state was set up. With this approach you have to do it as a user would. So you have to invoke, for example, 5 API methods to end up in the same state. It's better from the business perspective, but it's more expensive and I would say longer to write as a developer. But from the pros side, with those tests, we know that when test fails, it just means that we broken something. It's really great experience to know that you've broken something when it's red, not that you just change the name or change the structure and now you have to refactor also the whole test. So that's a big pro for us. Also another pro, a minimal amount of mocks. So we mock only the database and external clients to see, to spy on them and to return the values that would be returned on production. So we have no mocks of the classes that are like inside our system. All tests are similar to each other because all tests invoke API to set up, invoke API to invoke the business logic, and then invoke API to check the state of the system. So that's also helpful, especially for new joiners, because a new joiner can easily dive into such tests. He feels it's just easier to dive in the one testing approach than into 6 testing levels. And such tests also work as a documentation for new joiners, so he can learn how the system works through by reading the tests. Once I was told that I can do the same with class-oriented tests, but I would not say that reading tests with mocks do the same for me. It's about classes, not about business features. So was it a good decision for us as a team? Yes, it was so good that when we started another project from scratch, we didn't have any discussion. We just used the new approach because those pros really overweight the cons of the approach. So we would use it in any new project that we create. We have also the ghost of testing futures, so what can be improved. And if you look at the slides, you know what. So there is one big elephant in the room, the startup time. So 44 seconds is a really long time to start a single test. If you look at the graph that shows the structure of the startup time, you can see that the DB migration takes around 42%. So first thing that can be improved is to keep DB running on your local machine or in the cloud, and that just, it's almost half of the time, so big improvement. You can also optimize the Spring context. We never did that, but if you limit the packages that are scanned, disable some not used features, it can be much faster. You can also experiment with the ahead of the time compilation, like GraalVM. We never did that, but it's on our to-do list. And if you want a new computer from your employer, just ask him for the M1 or better chipset. It's a good reason. You can just say to him that it will save his money because you won't waste the time for Facebook. Yeah, so that are some things that you can do to make the pain smaller around that 44 seconds. Here are some references about this testing approach. I didn't know that software engineering at Google Book says about it, but when I prepared for presentation, I found out that it says exactly about the testing type of testing we did. There's also a sample of such tests with Fein client. It's a library that generates your API clients based on Spring annotations, so it's really easy to use it. And that's all. So thank you for your attention.